So we started talking about this last time, and today I want to go into serious detail about this. And like I said, it's a place where we tie together all sorts of pieces of the course. The statement today is that mutations in genes that encode proteins that control growth sometimes can lead to uncontrolled cell division. That is, if you break them in the right or wrong, depending on your point of view, you break them in a specific way, then sometimes that can lead to cancer. And so I want to talk about that today in some detail. So let's get started with mutations. They are changes in DNA sequence. And they are random. So like you guys saw in APOE2/3 this week, right? You guys looked at your mutants you made way back when in genetics. And if you were most likely what you saw as a single base change made that new allele, that new colored allele. And you could actually trace in the last part, you can see that single base change changed a codon or whatever, did something to your gene and changed the color of the protein it expressed. So it's a random change in DNA sequence. So the simulation of mutations in APOE2 is exactly the way mutations work in real life, except with a slightly higher frequency than normal. And there are at least two flavors of mutations. There are sort of natural or background. And that is, DNA polymerase does its very best not to make mistakes. It is extremely good at copying, 1 error in 10 to the minus 10 or something like that. But that means it still sometimes makes mistakes. So there'll be mutations no matter what. Right? Some small number. Also, we are constantly exposed to radiation from the sun, from the people sitting next to you. It turns out people sitting next to you are slightly radioactive. The chair you're sitting on, the air you breathe, everything's a little bit radioactive to varying degrees. And so always there's DNA damage from that. And oftentimes that gets fixed, but not always. And we're always exposed to chemicals of various sorts, even if you lead a very clean life, that might damage your DNA. Right? And so there's always going to be some background of mutations. You can never have a no mutation life. However, you can make things worse. And those are mutations due to mutagens. Agents that cause mutations. Those are, I mentioned these briefly before, they're chemicals or radiation that increase the mutation rate. And I said that once long ago, but what I want to talk about now that we have all the pieces in place, we can actually explain how an example of how they work.